All right, welcome back, everyone. My name is Dustin, and today we're tackling one of the most controversial patterns in C++ and other programming languages as well, the singleton. We're also going to look into monostate, dependency injection, and service locator to see which one rules them all. So let's go. All right, so let's start with the singleton, everyone's favorite or least favorite pattern. A lot of people call it an anti-pattern as well. But what is a singleton? A singleton ensures that only one instance of a class exists throughout the program and provides a global access point to that instance. Think of it like a president of a country. There's only one president ever at one time. You don't create a new president for every state, province, or whatever. You just use the existing one or refer to that one whenever it's needed. So the first thing we're going to do right now is write a simple singleton pattern to explain it further. And we're going to do a logger. So let's do that now. Okay, so right here, we're going to include a few things. We might not need it now, but we'll definitely need it later. So memory and include IO stream. Or you can use FMT if you want to. FMT, actually, let's include FMT as well. I'm using FMT. If you don't have FMT downloaded or installed, you could use the regular STD format. But I'm going to use FMT format. Cool. And we're going to create our logger. So class logger. And it's going to have some public, private. Cool. We don't want the user to be able to create multiple instances of the logger. So a way to prevent that is to make the constructor private. Okay, so we have to go logger, and that's equal to default. And we can do the destructor as well. And we're also going to want to make sure that this is not copyable. And to do that, we need to delete the copy constructor and the copy assignment operator. So let's go logger const logger reference, go to delete, copy this down, change this to a reference, go operator. So now this is a true singleton, well, will be a true singleton shortly, but now we're unable to make this outside of the class. So if we come over here and we go logger, it won't let us do it because it won't be able to access it. If we go here, it's inaccessible. Okay, so that's great. Get rid of that. If we're not able to actually instantiate an object outside of the class, we need to provide an access point or a global access point, and we can do that up here. And you do that through a static, and we want to return a logger reference, and we want to go get instance. Cool. And we can just do everything in line for now. No need to make CPP files or extra files because this is just a demonstration. So what we're going to want to do here is just go static logger instant and just return that instance. Return instance. Now, since C++11, it's guaranteed that there will only be ever one local static object created. So even if you use this in a multi-threaded program, it will not create multiple. It'll only ever create one. So this is our global access point. In order to use the logger, we need to use the get instance, and this will return a reference to the logger and then whatever functions that we need to use. We'll just create a simple function, just void log const std string reference message. We're not doing anything too crazy here. Let's just include some string things like string. We might not need it, but I'm going to put it in there anyway. String. So log, we're going to go fmt print, or you can use stdc out, but we're going to use fmt print, and we're just going to say square brackets log. That takes in that, and then right here we'll just go message. So all this is going to do is take the message and plug it in here, whatever that message is, and it's going to create a new line as well. Pretty straightforward. So let's actually just make a little function here. So we'll go void run singleton, and we'll just say logger get instance dot log singleton logger action. And we come here and we go run singleton logger and run. Cool. There you go. Singleton logger in action. Pretty straightforward. It ran the singleton. It got the instance. And if we go here and we go logger is equal to logger get instance, it won't allow that either because we have made that inaccessible and we also deleted it. So right here, so we're not able to, this is the assignment operator. We're not able to just assign, but if we make this into a reference, that'll work fine because we're not copying, right? So we're getting back a reference to this instance and that should work. And then we can say logger.log referenced log, and that should work. Awesome. So at any moment at any time, it's always going to be the same logger that you get back. And this can be a good thing. So let's look at some pros. So what are some pros to the singleton pattern? You have global access. It's easy to get the instance anywhere in the program. You have a controlled lifetime, constructed only once and usually lazily. It's thread safe since C++11 with all static local instances. This is thread safe. Well, create one, it's thread safe. To use it, maybe not. So what are some cons to the singleton pattern? There are hidden dependencies. So say we have another class that uses this logger, but we're not telling anything in your H file or your API. You can't tell that it's using a logger. It's just in the CPP files, which could be hidden or not available to the user. Nothing in your function is telling you that it relies on the logger. Also, the singleton can be hard to test. You can't just swap it out in a unit test. You have to use the actual instance of it. It also will break modularity. Everything starts to depend on that singleton, and you can't really move away from it because it creates that coupling. Initialization order problems as well. In more complex versions, you might break something, and I noticed this before. I was still trying to log something, but however, it was tearing it down, so it would cause some type of exception. You want to try to watch out for that. So should you ever use the singleton? Of course, but when should you use it? When there truly is just one instance of that needed. When performance is critical, that matters as well. Also for things like OpenGL context or something where you own, or a window manager, you only ever need one, so a singleton could work for that. So when do you want to avoid singletons? You want to avoid it when there's multiple instances might be useful. I remember when I first made my game engine, I had the registry as a singleton, and that was a bad idea because I found out later on that I could have multiple needs for that same registry, or I could use multiple instances. So I ended up changing that from singleton and made a registry that I wanted to be a singleton. I did a wrapper around a registry and called it the main registry, and that one was a singleton. However, the underlying registry is not, and I could use multiple instances of it. And you also want to avoid it when you need testability or modularity. A good alternative would be to use dependency injection, and we'll get into that later on. All right, so now we're going to look at the monostate pattern. So what is the monostate? The monostate looks like a regular class, but under the hood, it shares state between all the instances. Okay, so it's like a singleton in disguise. It has a shared state without a global instance. So how does it work? The monostate looks like a regular class that can be instantiated multiple times. However, it shares the state across all instances using static member variables. So here's an analogy for you. Imagine a radio station. No matter how many radios you buy, they all tune into the same broadcast. The station, or static variables, determines what all radio instances hear, okay? So that's basically what a monostate is, and we're going to start looking at that right now. Let's create a monostate logger. So we have our singleton, and we're just going to go underneath here, and we'll just call this the class mono logger. Cool. And we're going to do the same as before. We're going to say public, private. In our private, we need to now provide something that is shared amongst all loggers. And for this one, we're actually going to make it thread safe, or try to make it thread safe. And we're going to go inline static std mutex. Now I'm going to have to add that in. Let's go to the top. Let's add in mutex. Might as well add in thread while we're here as well, so we can test it on different threads. Mutex and thread. Cool. And go down. All right. So we have our mutex, and this is static. So that means all monologgers that are created will share this mutex. Okay. So let's go up here and create a function. Let's say void log. We can actually probably just copy the log from up here. Let's do that. Up here, we'll just copy the same log. Down. paste. The only difference is we're not going to use fmt print here because fmt print, from my testing anyway, it's thread safe. It won't allow them to print over top of each other, where std-cout is not. You can make all your printing all jumbled and jumbled up because based on the threads, it won't be waiting for the other one. They'll just be pushing to the output. So let's change this to std-cout, but we need to add in iostream for that. So include, if I can type, iostream. Cool. So we have iostream. Let's go back down. And in this here, let's remove this and go std. Cout, move this, and it's going to be our message, and then cool. So now we're going to actually want to have a lock guard here. So we want to go std lock guard block, and that's going to take in my mutex. Okay. In order for this to work, any monologger needs to have access to the same mutex, because if this one's locked and they're all sharing this mutex, it will allow the print to work correctly without jumbling everything up. And let's do a test for that. So let's go and create a new function, and we'll say void run mono from thread. That's going to be int thread index, and we're going to say mono here. We'll just say logger here, create the logger, and it allows us to create the logger because there's nothing preventing it. Okay, so our constructor, this is going to create a default constructor. You could probably do that too. Let's do that as well. Mono logger is equal to default. Should have a default destructor as well. Logger default. Oops. Default. Cool. That should work. We'll see what happens. So we're going to create this from the thread, and we're going to loop 5 times, and each time we're going to print from the thread. So we're going to say for int I equals 0, I is less than 5, plus I. Cool. And then we're going to want to say logger.log, and this is going to be fmt format message from thread, and then over here send in I and thread index. Now that's not necessarily the thread ID, but it's just the index of what we created. And then let's sleep this thread. So std this thread sleep for std chrono milliseconds, and let's make that 100. Sure. So what it's going to do here, it's going to log, and then it's going to sleep the thread, right? And the cool thing about the lock guard is it will automatically unlock itself. If you go back to the RAII video that we made explaining that, it'll make more sense to you. But this will automatically, so it's created here, it will lock the mutex, and upon leaving scope, it will unlock it automatically. Cool. And then right here, let's create another function that will create those threads. So let's go void create mono threads, and we can say const expr int thread count. We're going to want 4 threads, and we're going to need vector because we're going to want to have a vector. Oh, I already included at the top. Sorry guys, you probably saw that. That was silly of me. Let's include a vector. Cool. So now that we have our vector, let's create a vector of threads. Std vector std thread, and it's just going to be our thread. And then here we can go for int I is equal to 0, I is less than thread count, plus or plus I. In this case, it doesn't really matter. We can go threads dot in place back, and we want to say run mono thread, and then I. And then we're going to want to loop through all the threads for auto reference thread in threads, and we're going to go thread.join. Thread.join. Cool. And if we come down here, we can comment this out for now and go run. Oh, wait, no, hold on. We can just do the create mono threads. That should work for us. So we go copy this, paste this here, create mono threads. And what this is going to do is it's going to run and print all the threads. Okay, run it. Awesome. So as you see, everything looks clean and nice. The only way that the mutex would be locked is if they're all sharing the same state. That's where monostate comes from. They're all different loggers, but they're all on different threads, but they're sharing the same state. Okay, so let's close this and let's get rid of this lock guard so it makes more sense. If I get rid of this lock guard that's shared amongst all monologgers, now the output's going to be all jumbled up because you're going to have races all trying to use the same output. Let's run it. Bang, look at that. They're all over the place. They're like log messages. That shows that the monostate was actually working because it was using the same mutex. So let's put this back in and run it. Look at that, nice and clean, good to go. Okay, so what are some pros to the monostate? So the monostate is easier to test than the singleton, and you can create and destroy instances rather than having it live the entire time. However, there still is a global state, but there's no need to use the get instance here. But you still have a global state amongst all loggers. They're all sharing something. And it's copyable and movable, unlike the singleton. Singleton, where you can only ever have one. Okay? So what are some cons? You still have some hidden dependencies like the singleton, and it's difficult to track the shared state changes, right? If the lock changes, or say you're using something else for your shared state, it's hard to track that. So that's the monostate. So what if we want full control and flexibility? This is where we want to start using or thinking about dependency injection. So what is dependency injection? Instead of relying on a global state like singleton or monostate, the class receives its dependencies from the outside. So you need to think of it like a coffee machine, where a bad design or a singleton would make it fetch the water itself regardless of where you put it. A good design or a dependency injection lets you inject the water so the machine works anywhere. Say you need a logger in a different class. You're going to want to pass that in as a reference or a dependency, so it's passed into the class. That means the logger must be created beforehand and passed in, because you cannot have empty references. Okay, so let's actually create a service and a new logger that will be passed in as a dependency. So we'll go down here and we want to keep these functions. That's fine. Cool. Right here. And let's add in a new class, and we're going to call this DI logger. And it's going to have public, it's going to have private, DI logger equal to default, the destructor as well. Let's have a function, and this one is just going to basically be the same as before. We'll use FMT for this one, so we'll just copy this one up here. Copy this. Copy. Bring this down. Oh, we don't want these to be private. I'll just paste it here and move them all. So we want this. Take this. And let's actually have a prefix. So we want to go std string s prefix. And the prefix is just going to be simple. It's going to be same thing. It's going to be log. So we have a prefix. Now, the reason why I want to use this prefix is because we're going to use this DI logger later on. And I found that if you don't have any member variables or anything like that, it will allow you to actually sometimes dereference a class that doesn't use this. Okay? And that's a problem. You can dereference a null pointer and it may still work. And we don't want that. We want some defined behavior. Okay? Away from that, let's get rid of this. Add this in here. Add our prefix. Cool. So now we have our DI logger. You can create as many of these as you want. It doesn't share a state. However, we're going to use this for our dependency injection. And to do that, let's create another class that will have the logger as a dependency. Okay, so we can go class, and we're just going to call this a service. It can be anything really. And we go public, private. And our private, we're going to depend on a DI logger. And this is going to be a reference. And we're going to call it the logger. So then here, we're going to say service in our constructor. Now it must have a DI logger reference logger passed in. It must be there. And we have to go logger log work. All right. So we have our service. We can put this up here. And it depends on the logger. If we didn't pass this in, right? So say we did this. Let's actually just copy this line down. Comment this out. Don't pass this in. Get rid of this. Now it's going to give us an error here. The initial value of a reference to non-const must be an L value. We must pass in the reference there. Or if we take this out, totally, it's going to give us an error as well. See? Provides no initializer for the logger. So we need to do that. Get rid of this. That in there. Cool. And let's just have a void do some service. And it's going to be logger.log depend injection. Cool. So we have our dependency injection in action. And this should work fine. So let's go and create a new function to run it. We can go void run DI. Let's just say dependency check. So we're running our dependency injection function. We need to create a logger first. So we go DI logger. We create our logger. And I need to pass that into the service. So if I go service and I go service, but I don't pass in the logger, it's going to have no default, right? So there's no instance of the constructor that matches this. So we need to pass the logger in. Pass the logger. And then we go service dot do something or do some service. And that should work fine because we're passing in our dependency. And the cool thing about this is it's telling you right in the constructor, hey, it depends on this logger. It needs this for some function because you might not see this function, but it's like, hey, I still need this in order for this to run. So it makes sense to the user what this class or the service depends on. Okay, so let's bring this down here, comment that out, run. That should run just fine. Awesome. So that makes sense and it works, and you can use it for many different dependencies that you want to add in or different things that this service must have. And that's pretty cool. So say it needs to have something like a window manager or something like that, or needs to take in, you could pass that in as a dependency or like a context, and the context could have multiple things. You can, and those can all depend on something, and then you pass it all in and it eventually comes down to you. Okay. What are some pros and cons to dependency injection? Dependency injection is highly testable. You can pass mock objects in for the unit tests. It's more flexible. You can easily swap different implementations. There's also no global state. Explicitly defines the dependencies, and you can see them directly in the constructor of the object that you're trying to create. And then cons, there's more boilerplate code. It requires passing objects around. So it's harder to manage in large projects. And then you have to pass dependencies in manually. So if you look here, we have the service. Well, it needs to have this passed in. And if I didn't create this here or didn't have this created somewhere else, I couldn't pass it in here. Okay. So it needs to be an L object or L value object. So something that already exists. So what if you don't want to pass things around manually? Well, then you can have something called the service locator. Now, what is the service locator design pattern? Instead of passing around dependencies manually, like dependency injection, you register services in a central locator, and your code asks for them when needed. Think of it like a phone book or a reception desk. You don't pass every service to that part of your program. Instead, you need something like a logger, audio manager, etc. You look it up in the service locator. Okay. Another good analogy would be a video game engine. You don't want every class to carry a sound manager, a logger, an input handler, etc. Instead, classes just ask the service locator when they need one, like a butler that fetches services for you. Okay, so let's actually write a simple service locator. Writing the service locator is a bit more complicated, but we can do it right here. So let's go class service locator public, and we're going to say template type name. Bring this all the way here, make some space here. Now, the first function I'm going to want to make here is to provide. You need to provide the object to the service locator before you can use it. Okay, so we want to go static void provide. So we're providing the service std shared pointer, and it's going to be of t, and we're going to call this a service. Okay, so we have our service, and before we do that, let's go private. And let's actually define what a service is. So down here, we're going to create a new function, and it's going to be called instance. Now, if we go back up to the Singleton logger, we have this function here. So this is going to guarantee that there's only ever one made. So we're going to want to do the same thing for our services. Okay, so let's go down here to our service. And here, I'm going to want to go template type name, static std shared pointer reference, and it's going to be instance, kind of like get instance. You can call it get instance if you like, or we can just do it like this. And we're going to make it a static local variable std shared pointer service instance, and we're going to return that instance. Return service instance. So whenever this is first called, it's going to be returning a null pointer. We can actually make it explicitly null here if we want, so you know. So we're returning it as null pointer. The first time this is called, it will call this. It won't call this multiple times. Okay, so the first time we call this, we're going to want to be setting it to the instance that we provided. Okay, so let's go back up into our provide function, and let's do that. So once we're providing, we're passing in this service. So we're going to want to call instance, and that's instance of t. So whatever service that we are providing it, right? Because it's the template argument. And what this is going to do, it's going to return null pointer first. Okay. So right here, this is actually returned a null pointer to a t object. Okay. And then it goes std move service. So what we're doing here is we're moving this pointer into this. So now whenever we try to get this, it won't be null pointer anymore because we actually passed it in a service, unless we pass it in a null pointer, but then that's something else. You could put a check in for that, but we're not showing that. This is just a simple example. Okay, and let's have a way for us to get that service. So let's go template type name t, and we go static t reference get. Now we're just going to want to return the dereferenced instance of t. So this returns a shared pointer, so we need to dereference that to get the reference, right? However, what if this is null pointer? Well, that's because we didn't provide it. If we didn't provide it, it will actually crash the system. And that's one of the drawbacks of the service locator, and one of the pluses, I guess. You must provide the service beforehand, so it must already know about the service. So let's actually create a function to test this out. We're going to say void run service locator. Oh, need something here. Run service locator. Cool. We can take that line away. First thing I'm going to want to do, I'm just going to use the DI logger that we created because it doesn't need anything. So let's actually provide that to the locator. So we go service locator provide DI logger. And we're going to say right here, we're going to just pass in an std, make shared, and it's going to be a DI logger. That's it. So we're providing it an actual object that we're passing in, and it's going to automatically be used there, or an actual pointer. Now we want to get the logger to test it out. So if the logger wasn't provided, this will end up being a null pointer, or dereferencing a null pointer inside of the get. And we'll test that out in a minute. So let's go auto reference logger equal to service locator get di logger. And I want to go logger.log service locator in action. Cool. And let's run this. Grab this, paste it down here, paste, get rid of this for now, and run it. Bang! Service locator in action. That's perfect. And that works because we provided it the service that we want to use. But what if we don't provide it? In this case, it'll run, but it's going to crash. Well, it should crash. Bang! Right here. Because it doesn't exist. Let's check out our call stack here. And we'll go to log. So it's trying to use this, but this is null. It's struck at null. You see that's not there. So that's why I had to put this in here. If I remove this, for some reason, even though it's undefined behavior, it will still work, right? So let's actually just comment this out. This is a test here. Comment that out. Now, I found this the other day when I was doing some tests, that this will actually still work, even though it's returning a null pointer. Hold on. Oh, yes. Let's just take that and get rid of that. Because it was expecting multiple. Run it. See how that worked? Isn't that crazy? And this, we know that this is null pointer because we didn't provide it. So the instance is going to return a null pointer here. Let's actually put a breakpoint here. Run. So right now it's empty and we're returning empty. This is an empty service instance. We keep going, it returns the instance, and this is empty here. And we're actually going to dereference an empty object here. So let's keep going back. Right? So right here. Run down. Check this out. Struct at null. But it's at null, but we're using the function and there's no member variables. So for some reason, it allows this, even though it's undefined behavior. And we don't want that. So that's why I added in that prefix value. Okay. Stop this and go back up here. Go back. Cool. And run it properly. And now that should crash because that's what the goal for us is, for it to actually crash if we're using it, if it doesn't work, or if it's not set up correctly, we didn't provide. So now we provided it. Let's go back and fix the provide. So we're actually providing it what it needs. So this won't be null pointer any longer. Run it and it should be good. Awesome. Good to go. Okay, so what are some pros and cons to the service locator? So some pros are you have global access to services without a true global state. It could still be used anywhere, even deep in the code, and it still allows for mocking and unit tests if done right, okay? So what are some cons to the service locator? It still has hidden dependencies. It's not obvious what a class needs, like dependency injection. You can see directly what that class depends on. It can lead to tight coupling of different areas or different modules. It's also easy to overuse, turning it into like a god class where you put everything into the service locator when it's unnecessary. All right, guys, so which one wins? Which is the best, that one that you should use? Well, it really depends. You're going to want to use a singleton when you really only need one instance, something like a window manager or something of that nature. You ever only need one. Monostate is when you want shared state without the singleton restrictions. So it's sharing certain things through static variables. However, you're able to create multiple instances, okay? Now, when you want dependency injection, this is when testability and flexibility matter the most. You want to be able to see the dependencies up front, and you want to be able to use mocks and things for tests as needed. And then the service locator is when you need global access to something, but you want some flexibility, okay? So no pattern is inherently bad. It just depends on what you need and how you use it. It's easy to overuse every pattern that's discussed here. And that's a wrap. That's it for this video. Which pattern do you prefer? Let me know in the comments below. Also, make sure to like and subscribe if you haven't done so already. And add in the comments below if there's any other things you want me to try to make a video on. And that's it. Take it easy.